Hey everyone, my name is Will Valida. I'm a software engineer and cloud architect, and in this video we're going to be talking about Radius. Now, Radius is a new cloud-native application platform that was released by Microsoft last year, and it's designed to bring developers and platform engineers together to help them build and operate cloud-native applications. Now, this project is still in the very early stages of development and it's not quite ready for those production workloads, but I've been spending a bit of time exploring it and it's looking a little promising. So in this video, I'm going to talk about what Radius is and what problems it's trying to solve. Then I'll cover some key concepts of Radius before demonstrating how we can provision Radius environments and build Radius applications. So let's start by talking about the challenges of building cloud-native architectures and particularly microservices. Now, microservices can be complex. You might have had a conversation with your colleagues in the past when you're building new systems and someone might have mentioned, hey, why don't we use microservices for this? And you might have responded back, well, do we really need microservices? And we ask this because they're complex to build and maintain, and they can kind of result in complex architectures that no one really understands as complexity grows and more services are added to it over time. We have to think about how and where we're going to deploy our microservices. Can we deploy to multiple clouds? We might have to deploy to both Azure and AWS for high availability and disaster recovery reasons. So ideally, we need a framework or we need tools or a platform that enables us to do that. We also need to ask ourselves, how can we enforce best practices for our workload that's kind of easy to manage? We want to make sure that the workloads that we deploy to the cloud and the workloads that we build enforce best practices that comply with a wide variety of different requirements. So whether they be security or performance or even cost management requirements, we need a platform that helps us do that. And then finally, we're going to need a way to operate our microservices and troubleshoot them when things go wrong. As you can imagine, with distributed architectures all over the place, it can be quite challenging to see what's gone wrong and where it's gone wrong. So we need a platform that helps us troubleshoot our architecture in a way that's easy to do. And one way that we've kind of attempted to solve those problems in the past is use something like Kubernetes. Now, standardizing on Kubernetes has been successful for most enterprises, but for anyone who has used Kubernetes in anger, you'll know that this comes with a lot of complexity, and sometimes more complexity than it's worth. We don't just run our applications on Kubernetes. We have to think of a variety of different things. We have to think of message brokers, storage systems, container registries, and maintaining and operating all of our resources that make up our application is a full-time job in itself. That's why we have platform engineers, site reliability engineers, DevOps engineers, even though I'm not a huge fan of that title. And because of this, we can end up in situations where we create silos within our organization. So we could have silos where software engineers kind of sit in one corner building their application, and then they kind of throw that code over the wall. That's a term that I've heard in the past. And they throw that to platform engineers who sit in another silo within an organization. And this is a problem because we shouldn't and we don't develop in isolation anymore. To develop the type of complex applications that enterprises usually build, we need developers, platform engineers, IT operations folks to all collaborate together. And the tools that we use and need to use in our day-to-day work need to aid that collaboration, not impede it. Now, another problem we might have with those silos is that platform engineers that kind of support the applications that we build may lack context about the architecture, while application developers will lack the context about the underlying cloud infrastructure that their applications run on. So together, we need to have a way of having that common understanding and being able to visualize what our applications are and how they're actually deployed to those cloud platforms and infrastructure that they run on. And this is where Radius comes in. So Radius is an open source cloud native platform that enables developers and operators to develop and collaborate on cloud native applications across public and private clouds. Now, the only reason I said that so clearly is because I stole it from their website. But essentially what Radius is, it you will have your developers who will define their applications and their dependencies, and your operators will define the environments that those applications run on. Radius kind of brings them together, deploying applications and infrastructure that meet both requirements of developers and operators. Now, Radius applications are designed to be cloud and platform agnostic, so whether you're deploying on Azure or AWS or on-prem, you can build Radius applications. Once you define your application, you can deploy it to any cloud or platform that Radius currently supports. So recording this video in 2024, I was going to say 2024, no one says that, February 2024. Currently, it's only supported for Azure and AWS. For those of you deploying onto GCP, it is coming, but I don't have a timeline for you. And this is great for when we need to move our applications between clouds, or if we have on-prem applications and we're moving them to the cloud, or if we're deploying to both clouds for kind of those disaster recovery and high availability scenarios that I touched on a little bit earlier. So using Radius, developers can define their requirements and dependencies, and operators can define their environments and use recipes to bind those requirements to appropriate cloud resources. And I'll talk a little bit about recipes soon. Now, Radius applications are the primary resource that bring all your services, dependencies, and relationships together. Essentially, you'll have a single description of your application, allowing you to deploy and manage your application easily. Radius applications capture this via an application graph, which helps us deploy and understand our applications better. So if you take this example here, we might have a UI for an e-commerce site that talks to a backend container, which then can talk to a SQL database. We might have some caching on that website, so we need a Redis cache, and then we can expose that to the public internet using a public gateway. So when we define our applications, we essentially deploy them to environments. Now, environments in Radius provide a landing zone for applications that's configured with the organization's chosen best practices, settings, and recipes. And essentially what environments are, they're an encapsulation and they store configuration for the compute platform itself. It's also network configuration, diagnostic, and any other operational concerns that you might want to implement. Now, you can configure environments to vary across different types of deployment. So you could have an environment for your staging environment or for your production environment. If you're deploying a multi-region application, you could have environments that deploy to different regions. And like I said earlier, Radius is designed to be cloud agnostic. So you might have environments for different clouds. Platform engineers will collaborate with app developers by managing the set of environments that developers can use. So when an application is deployed, Radius will bind the app to the configuration of the target environment and then apply those relevant settings that platform engineers have defined for that particular environment. And this is great because operational configuration in the environment will actually help increase developer velocity because the app doesn't need to change when it's deployed across different environments. The application is just what it shows in the application graph and it binds to the environment. So the environment holds the configuration for that particular environment and the application will bind to it. Now, I've talked a lot about recipes. Now, recipes are a key concept in Radius. What they do is they enable a separation of concerns between IT operators and developers by automating infrastructure deployment. Now, so as a developer, you will select the resources that you want in your applications, and platform engineers will then codify their environment to show how these resources should be deployed and configured. So when a developer deploys their application and its resources, recipes will automatically deploy the backing infrastructure and bind it to the developer's resources. Now, currently, recipes support both Bicep and Terraform. You can use the recipes that Radius provides. There are some recipes that Radius provides out of the box, and I'll show you how that works in the demo later. Or you can create your own custom recipes. So if you go back to a caching example like I showed earlier, If we're deploying to Azure, so that'd be an Azure Redis cache, we might want to integrate that into a VNet. We might want to set some diagnostic logging on that. We might need to create a private endpoint as part of that VNet integration. So what platform engineers can do is essentially codify all of that up, expose it as a recipe, and then developers can just consume it as a normal cache without having to worry about, okay, I need to set up this Redis cache to integrate within the VNet, because that's already done for them. So I've been talking quite a lot about the concepts of Radius. So now what we're going to do is we're going to jump into our demo and build our first Radius application. Okay, so for this demo, what I'm going to do is I'm actually going to follow along with this tutorial that's provided on the Radius documentation. I'll include a link to this in the notes. But here, what we're going to be doing is we're going to define and deploy a Radius environment and application. We're going to add a container to our application, then we're going to customize it a little bit. Then we'll add a MongoDB database to our application and connect it to our container. Then we'll add a second container, which will then connect to our first container. And then we'll expose our application to the internet through Gateway. So by the end of all of this, we'll have kind of this architecture deployed. So we'll have our gateway that's exposing our front-end container, and that's going to be talking to a MongoDB database and a back-end container. So before we can get started, we're going to need three things. We're going to need a supported Kubernetes cluster. We're going to need to install the RAD CLI. And then we're going to need the Radius Bicep VS Code extension. So what I'm going to do, just make sure I'm in the right one. I've got too many tabs open. So to start off with, I've just got an AKS cluster that I've deployed to my Azure subscription. So that's going to be perfectly fine to deploy our Radius application. So I've got my supported Kubernetes cluster. Now the RAD CLI, so if I open up my command terminal, I'll just clear up the output a little bit and just type in RAD. I've already installed it, and this Radius CLI is essentially going to send requests to the Radius API. So essentially what we do is when we're building our applications, we can use the Radius CLI to make operations and make requests to the Radius API, and then that routes the request to particular service providers, whether that be Azure or AWS. To install that, if I just open up that in a new tab, the Radius team have kind of built a how-to to install the Radius CLI on your local machine. So whether you're running on Linux or PowerShell or Windows like I am, you can also run it in GitHub code spaces. It's also available in the Azure Cloud Shell. You could also download the binaries as well if that's what you prefer. Cool. And then finally, we've got the Radius Bicep VS Code extension. Now, what I've got here is I've got my Visual Studio Code. I've got an insiders version that I'm using for this. And the reason why that is, this is the extension that we're going to be using for our Radius applications. So if I just scroll down a little bit on there. Essentially, what this is a temporary fork of the official Azure Bicep repository. And they've done that just to support Radius while they kind of like work on it before kind of merging it back into the official Bicep repository. Now, while this extension is available, we run into a problem where you can't actually run the Radius Bicep extension and the official Bicep extension side by side. So to kind of get around that, I've got the Bicep extension installed on Visual Studio Code. So I got the insiders version and just installed the Radius Bicep extension on that just to keep those two separate. Cool. So I'm just going to minimize that, take that to my next screen, and we're going to get started. So what I'm going to do, I'll go back to Visual Studio Code Insiders and just open that up a little bit. The first thing I want to do is initialize a new Radius environment. I'm going to do that using rad init. And what this is going to do is it's going to get me up and running with a local development focused environment where most of the environment configuration is going to be handled for us. So that's going to include a bunch of recipes. We can fully customize our environment if we want. There is a command, we'll just add a flag full to the end of it. But for now, I'm just going to initialize a standard environment. and I'm going to set up a new application. Well, I set up an application in the current directory, so I'm going to click yes. So what that's going to do, it recognizes in my current kind of kube config that I've got my Kubernetes cluster that I showed you in Azure earlier. It's going to create a new Kubernetes namespace for me. It's going to create a new environment, so that's default. It's going to deploy that to the default Kubernetes namespace. There's a recipe pack that comes with that, so there's a bunch of local recipes that Radius provides, and it's going to scaffold an application to kind of do that for me. Cool, so that's all installed for me. Now we've got our Radius application initialized. So what we can do is we can actually start to inspect our application. So what I'm going to do is just clear up the terminal a little bit, and I'm going to view my full application definition by running rad app show my Radius app. That's going to be the name of my application, so I pass that through as a parameter. I'm going to output that in JSON. And what we should see here is the full app definition in its raw JSON format. Now, there's a lot of information here, but the important things to note is the first one is this ID property. And what this is the fully qualified resource ID for the application. So this is used to kind of identify the application within the Radius system. Now, you may think this location is set to global. So this is where your application resides. Now, at the time of recording, all applications are deployed to kind of a global location. But essentially what this location is really corresponding to the cluster where Radius is running. So my AKS cluster is deployed in Australia East, because I'm living in Australia at the moment. So essentially my application is residing in Australia. Now this environment property here specifies the Radius environment which the application will bind to at deployment. This is what determines where the containers should run. So the containers are going to be running in Kubernetes, and to which namespace to deploy into. So it's prefixed with kind of this default namespace. So all of our applications are going to be deployed into the default environment that we created using that rad init command. And then finally, the compute will specify the hosting platform where running services in the application will run. So in this case, we're deploying it to Kubernetes. At the time of recording, Kubernetes is the only compute platform that you can deploy to. But essentially here we're saying, okay, this is the namespace within Kubernetes where we've installed Radius. Cool, so let me just clear up that terminal a little bit. So now what I want to do is take a look inside my application to see what's deployed. And I can do that by running rad app connections. So I'll enter that. And we can see that nothing has been deployed and it's empty, which is good because we haven't really done anything yet. So in order to do that, let's start to deploy some resources and start to build out our application. So as part of that rad init command, what would have happened is we've got this app.bicep file. Let me just close that for a little bit of real estate. That's going to launch the bicep language service in the background. But essentially what this bicep file does, it's going to define all the resources that will make up our application. And it's going to include how those resources are going to connect to each other. So with this, we actually get a huge benefit because then these application files make it really, really simple for us to consistently deploy and manage our application. So what you can see is that this kind of app.bicep file was scaffolded by that rad init command. So here we've got our front end container. There it's just going to pull down a sample image. Just undo that. And we're going to expose that port of this container on port 3000. So to deploy this, I'm just going to open up the terminal again. And I'm going to run rad deploy that app.bicep file. So I'm just going to enter that. And we should start to see our container being deployed. Cool, so our deployment has completed. So now what we can do is we can actually run that rad app connections command again. And what we should see is the container that we've just deployed. So there's our container. along with the underlying Kubernetes resources that were created to run it. Now, Radius environments, map how applications bind to a particular platform. So earlier we saw the application compute was set to Kubernetes and our namespace was kind of set to that default namespace. So this means that our container resources were deployed to that namespace in the Kubernetes cluster where we installed Radius. So it's actually installed in Azure Kubernetes Service. So now we've deployed our application, when we're working with Radius applications, we're going to want to access our container endpoints and view logs. So what I want to do, I'm just going to clear up the terminal again. I'm going to run that bicep file. So what that command does, it just makes it simple to deploy my application and automatically set up port forwarding and log streaming. So now that's being deployed again. And hopefully soon we should start to see a log stream from our container. Cool, so there's my log stream. So if I go to localhost 3000, let me just bring that terminal here. Here I can see the Radius demo container being that's running on localhost 3000. So I've actually exposed it on localhost 3000, but it's deployed it to my Kubernetes cluster, which is pretty cool. So if I go back to Visual Studio Code, I can see a bit of a log stream. Here it's making a bunch of GET requests to get a bunch of assets. And one nice thing about this kind of container image that the Radius team have provided, we can see Radius connections. So no connections have been defined yet. That's what we're going to do next. We can see some metadata about our container, so we can see network configuration, some process information along with environment variables. And we've also got this handy little to-do list to just kind of see how our container is interacting with external dependencies. So if I click on that, we can see that nothing's been configured, so everything's going to be stored in memory. So if I go test item, add that, that's essentially going to be saved in like an in-memory store that this application provides. Obviously, we don't want to hold all our items in memory when we're building proper applications. So what I'm going to do, I'm going to go back into Visual Studio Code Insiders, press Ctrl-C to terminate the port forward and log stream. So in addition to containers, we can add dependencies to our application. So this might include stuff like Redis caches or Dapper state stores or Mongo databases like we're going to do in this part of the demo. So what I'm going to do is get rid of that terminal. I am going to add a description, which will be the ID of my Radius environment. And this is set by the rad CLI automatically for us. That's going to be injected as a parameter. If I can type. And then what I'm going to do is just going to define another resource for my MongoDB database. So this will sit in data source, and MongoDB. There's all these bunch of providers that the Radius team have provided out of the box. They all kind of sit within this application namespace. So you might have seen some for data stores. You might have seen some for core functionality. You might have seen some for Dapper, etc. Essentially, I'm going to add my environment and application to it. So I'm saying that this MongoDB resource belongs to this application and this environment. One thing you might have noticed is when we added this MongoDB database to our application, we didn't specify how or where to run the underlying infrastructure. Because essentially what happens is the Radius environment and its recipes will take care of that for you. So just like how the Radius environment bound to your container to your Kubernetes cluster, it will also deploy and bind your MongoDB database to the underlying infrastructure using recipes. So this resource here is essentially what a recipe is. And we can actually learn a little bit about the underlying recipe that will deploy and manage this MongoDB database for us. So if I go back into my terminal, I'll just do a bit of CLS on that. And what I can do this by rad recipe showing it in the default namespace. I can do this resource type and use that namespace that I defined or used earlier for my MongoDB database. Mongo databases. So click enter. Not found. Okay. Okay. I must have made a typo somewhere. I'll see it in editing. Anyway, so yeah, essentially I can run that rad recipe show default command, and I can see information about the details about the recipe, and this includes available parameters, whatever defaults might be applied to that particular recipe, and there's a whole bunch of recipes that Radius provide, and there's a whole repo that I will include in the show notes where you can actually learn a little bit more about them. So now what I want to do is I'll go back into my bicep file, and I'm going to add a connection from my container to the MongoDB database, which will indicate to Radius that our front-end container is going to need to communicate with our MongoDB database. So what I can do, just in here, I can type in connections, and then within this connections block, I'm going to say MongoDB, and I just provide the ID or the resource ID of that MongoDB database as the source. So now I've said that my MongoDB database is connected to this container. I'm going to open up my terminal again, and I'm going to run that application again by using rad run. So that's going to build and deploy my application. Cool. With the power of video editing, I can see that we're getting some logs from our MongoDB database. I can also see that our container has been port forwarded to localhost 3000. If I scroll up a little bit here, I can see that things are looking like they're starting to be deployed. I can also see that now, rather than just that particular container, I've also got the MongoDB database. So if I go back into localhost 3000, I can see now I've got a connection to my Mongo database. So if I open that up, I can see a whole bunch of environment variables for my MongoDB database. I can see some metadata for it. And now if I go back into that to-do list, no longer are we getting that warning that we're saving items in memory. So essentially now we've got a container with MongoDB, a MongoDB container that our containers can talk to, and items are being stored in there. So if I go back into Visual Studio Code, I'm just going to get out of this log stream. I'm going to clear this up a little bit. If I run rad app connections again, we should see the container and the MongoDB database that we deployed, along with the underlying Kubernetes resources that are created to help run them. Cool. Now, in addition to dependencies, we can actually add more containers. So I'm just going to go with that again. I'm going to add another container. So I'm just going to go down here. I'm going to define a backend resource. So a little bit earlier, I was talking about different kind of namespaces where different resources or recipes sit under. So here you can see there's a whole bunch of core resources, so applications, containers, environments, gateways, etc. There's one for secret stores. So there's a whole bunch of resources related to Dapper. Down here into messaging as well. So there's a whole bunch of stuff that Radius provides out of the box. But here I'm creating another container, and I'm going to name this my backend container. And for my properties, if I can type, I'm going to say this belongs to my application. I'm just going to use the nginx image, and I'm going to expose this on port 80. So container port 80. Cool. So there's my backend container defined. So now I'm actually going to go back into this front-end container. I'm going to add that as a connection. So what I'm going to do is name that backend, and the source of that, essentially, instead of a resource ID, I'm actually going to point it to the port that we're exposing it on. Backend, and that would be port 80. Cool, so now if I go back into my terminal, I'm going to run that again. So rad run my app.bicep file. We should see my backend container being deployed as part of our application. And with the power of video editing, we can see our logs coming through. So you can see that my backend container was deployed, demo container was deployed along with my MongoDB database. So if I go back into my Radius application, I should see that my backend container has now been added as a connection. So here I can see, yep, there's the backend port 80, our host name's backend, and we have all this information for our backend container. And there's my test item from before. Now, in our final step of this tutorial, let me just get out of that. We now want to expose our front-end application using a gateway. So at the moment, we've been connecting directly to our container on localhost 3000. In real-world applications, we wouldn't be doing that. So if I get rid of this terminal, what I'm going to do is I'm going to add a gateway resource to my bicep file. So I'm going to create a new resource. I'm going to call it gateway. Now this will sit under the core resources, so there it is. And I'm going to just name this gateway. I'm going to give it some properties so it's belonging to my application, and I'm going to define a route for it. So essentially, let me just scroll down a little bit there, get the path going, and I'm going to say that the destination will be on port 3000. So now, if I deploy that again, let me just get some real estate there. There we go, rad deploy my bicep file. Essentially what that's going to do, it's going to deploy all of my resources, so my demo front-end application, my back-end, the gateway, and MongoDB. And hopefully we should see a public endpoint as well available to us, which we can connect to for our application. Awesome. So with the power of video editing, we can see that now we've got this public endpoint. So we've got this public URL that we can hit for our application. So if I open that up, yes I do, we hopefully should see our Radius application. So rather than directing to the container, rather than connecting to the container directly by going to localhost 3000, essentially now we're connecting to it using the gateway instead. We've still got all our backend, or our Radius connections for our backend container and our MongoDB database. Open up my to-do list, and there we've added an item, and our previous item from before is still there. So congratulations, we've kind of successfully built our first Radius application. Hopefully you saw how we can use Radius to kind of build up our application over time. We can add different components to it, such as more containers, a MongoDB database, any kind of data store, message brokers. If we're working with Dapper, we can add some resources to support that. We can also add gateways to expose our containers. So using Radius, we can start to easily build up our application using recipes that have been defined for us. So if you can imagine working within your organization, you might have a bunch of recipes that your platform engineering team have worked on, and essentially all we've done here within our bicep file, just get rid of that terminal for a moment, all we've done is essentially called these recipes. So here we might say we want to deploy this MongoDB database to AWS or Azure. We might want to deploy a cache, which was really just an extraction for an Azure Redis cache. There's a whole variety of things that we can do, and this is really powerful to help that collaboration between developers and operators. Now, to do a little bit of cleanup, what we can do, just open up that terminal again. We can actually delete our default environment, and this will actually delete our Radius environment and all of the Radius resources running in our cluster. So just by running rad environment delete, that will go ahead and delete our resources. Cool, with our resources now being deleted, let's wrap up. So hopefully after watching this demo, you now have some understanding about what Radius is and how we can use it to build cloud native applications. Whether we're deploying to Azure, AWS, or on-prem, I really think that Radius has some really ambitious goals for kind of simplifying the whole process of building our applications and provisioning our applications. It's very early days, but I'm really interested to see where this project goes and how it actually helps platform engineers and developers kind of build out those cloud native applications. So if you want to learn more about Radius, I really recommend checking out their docs. Also check them out on GitHub. And if you're keen on getting involved and you want to contribute to the Radius project, they do have a Discord. So go and join their Discord, introduce yourself, get familiar with the project. Definitely check out the issues on GitHub that have been raised and see how you can help out, because the project is in its very early stages. So there's potentially a lot of scope here for folks all around the developer community to get involved and provide their input and really build a platform that helps to simplify deploying cloud native architectures. So thanks for watching. If you like this video, give it a like. If you have any questions or comments, please ask them in the comment section below. I'll add all the show notes in the description below, so all links that I showed during this video, you can actually click for yourself and explore at your own pace. So wherever you are in the world, I hope you're having a great day and happy coding. I'll see you all next time.